Hello viewers, I welcome you to this tutorial video. In this tutorial, I'm going to teach you the procedure for solving each question which will help you in your forthcoming mathematics examination. This video will help you and give you insight on areas you are weak and prepare you adequately. It will also make you perform well in your mathematics examination, be it Neco, WAEC, JAMB, post-UTME exam screening, and so on. Please subscribe to this channel, press the subscribe button now, and share this video, like this video. Thank you.
Question 1. Express 0.00037 in standard form. Here is the procedure for solving this. A number is said to be in standard form if it is rewritten in the form a multiplied by 10 raised to power n, where a is a number that can be any of 1, 2, 3, 4, 5, 6, 7, 8, 9, and n is index, and it can be a positive or negative integer. Start counting or moving forward from the decimal point till you get to the space between first digit and second digit. Place your decimal point there and note the number of digits. Then regard the number of digits jumped as your index. Hence, you are counting forward. Your index will have negative sign, that is, if it displaces digits of whole numbers, n is positive, but if it is decimal, n is negative. Let's check the solution. We have 0.00037 is equals to 3.7 multiplied by 10 raised to power minus 4. Now let's check how we get this solution. We have 0.00037. We have to start counting forward from the decimal point till you get to the space between first digit and second digit. Let's start counting to the first digit. 1, 2, 3, 4. We regard the number of digits jumped as our index, that is 4 will be our index, but because we are counting forward, we will regard it as minus 4, and this is our digits. Therefore, we are going to place our decimal points here. Now our answer now is equals to 3.7 multiplied by 10 raised to power minus 4. Question 2. If 210x base 4 is equals to 146 base 10, find the value of x. Let's check the procedure for solving this. For the equation to hold, we convert both sides to numbers in base 10. This is done by method of expansion in the powers. The powers of expansion start with n minus 1, where n is the total number of digits. Then collect the like terms, that is, the unknown numbers to one side and the known value to the other side. Then divide through by the coefficients of the unknown value. Let's check the solution. The first step here is to convert both sides to numbers in base 10. We can see that the second side is already in base 10. Then we are going to convert only this side to number in base 10. And for us to convert this to numbers in base 10, we are going to apply the powers of expansion. Now let's start. We are going to multiply this value by its base. This is the first one, this is the second, this is the third, and this is the fourth. 2 multiplied by the base raised to power n minus 1. By applying the power of expansion, plus 1 multiplied by 4 raised to power n minus 1, plus 0 multiplied by 4 raised to power n minus 1, plus x multiplied by 4 raised to power n minus 1 equals to 146. This is the first digit, second digit, third digit, and fourth digit. Then we are going to represent our n for this as 1, for this as 2, for this as 3, and for this as 4. We now have 2 multiplied by 4 raised to power 4 minus 1, plus 1 multiplied by 4 raised to power 3 minus 1, plus 0 multiplied by 4 raised to power 2 minus 1, plus x raised to power 4 raised to power 1 minus 1 equals to 146. 4 minus 1 we have 3, 3 minus 1 we have 2, 2 minus 1 we have 1, and 1 minus 1 we have 0. 4 raised to power 3 now is equals to 64, 4 raised to power 2 16, 4 raised to power 1 4, 4 raised to power 0 1 equals to 146. Now let's multiply it together. 64 multiplied by 2, we have 128. 16 multiplied by 1, we have 16. 0 multiplied by 4, we have 0. X multiplied by 1, we have x equals to 146. Let's collect the like terms. X equals to 2. Question 3. Simplify 2 whole number 1 over 3 plus, open the bracket, 3 whole number 3 over 5 divided by 1 whole number 1 over 8, close the bracket. Let's check the procedure. The first step here is to change the numbers into improper fractions. Then apply BODMAS by solving for the expression in the bracket first. Then change the division sign into multiplication sign. invert the fraction dividing and work out as for multiplication. Then add the fractions together. Let's check the solution. The first step is to convert mixed fractions into improper fractions. That is 3 multiplied by 2 plus 1. Here 5 multiplied by 3 plus 3. 8 multiplied by 1 plus 1. We now have 7 over 3 plus, open the bracket, 18 over 5 divided by 9 over 8. Then open the bracket, 7 over 3 plus, open the bracket, 18 over 5 multiplied by 8 over 9. Close the bracket. That is the inverse of this value. We now have 7 over 3. When you multiply this, we have 16 over 5. Then apply LCM to make the expression a single fraction. The LCM of the denominator here is 5. That is 3 and 5. The LCM of 3 and 5 here is 15. 15 divided by 3 multiplied by 7, we have 35. 15 divided by 5 multiplied by 16, we have 48 over 15. When you add it together, you have 83 over 15. Then convert to mixed fraction, because our options are in form of mixed fraction. So we need to convert this improper fraction to mixed fraction. We now have 5 whole number 8 over 15. Question 4. Find the sum to infinity of a geometric progression whose first term is 3 over 8 and common ratio 1 over 3. Let's check the procedure for solving this. Apply the formula for the sum to infinity of a geometric progression is equals to a over 1 minus r. Then substitute for the given terms. Let's apply the formula. Let's apply the formula for the sum to infinity geometric progression, which is equals to a over 1 minus r. Then substitute for the given terms. Our first term is 3 over 8. Now let's substitute. We have 3 over 8 over 1 minus. Our r here is 1 over 3. Is equals to 3 over 8 divided by 1 minus 1 over 3. Let's open the brackets here by applying BODMAS. The LCM here is 3. We now have 3 over 8 divided by, into brackets, 3 minus 1 over 3. That is 1 divided by 3 multiplied by 1. We have 3 minus 3 divided by 3 multiplied by 1. We have minus 1 over 3 equals to 3 over 8 divided by 3 minus 2. We have 2 over 3. Then change the division sign to multiplication sign. Then change the division sign to multiplication sign by inverting the second fraction. We now have 3 over 8 multiplied by 3 over 2. That is, when you change this division sign to multiplication sign, you are going to have the inverse of this term. That is 3 over 8 multiplied by 3 over 2. We now have 3 multiplied by 3, 9 over 8 multiplied by 2, 16, 9 over 16. Question 5. Solve for x if 128 raised to power x is equals to 0.25. Let's check the procedure. The first step here is to convert the decimal into fractions form. Then express the terms in the powers of the common base. Equate the equations, then divide both sides. Let's check the solution. Convert the decimal into fraction form. 128 raised to power x is equals to 1 over 4. When you convert this decimal 0.25 to fraction, you have 1 over 4. Therefore, when you apply the laws of indices, you have 4 raised to power minus 1. Then express the terms in the powers of the common base. When you express these terms in the powers of the common base, you have 2 raised to power 7 for 128. Then here you have 2 raised to power 2. Then cancel the base out and equate the powers. When you cancel this base, you have 7x equals to minus 2. Then divide both sides by 7. X now is equal to minus 2 over 7. Question 6. Find the amount if 240,000 naira is borrowed for 2 years at 8% per annum compound interest. Let's check the procedure for solving this. Apply the formula amount is equals to principal into bracket 1 plus rate over 100 raised to power number of years. Then substitute for the given terms. Let's check the solution here. Let's apply this formula. Let's substitute. We have to find the amount in the question. Principal is 240,000 naira into bracket 1 plus our rate. We have 8%, that is 8 over 100. Number of years, we have 2 years. Then A is equals to 240,000 into bracket 1 plus 8 over 100. We have 0.08 raised to power 2. A is equals to 240,000 multiplied by 1.08 square. A is equals to 240,000 multiplied by 1.1664. When you multiply the two together, you have 279,936. Question 7. Evaluate log 0.0001 base 100. The procedure for solving this: convert the decimal into fraction. Convert the fraction into powers form. Apply the laws of logarithm where log b raised to power c base a is equals to c log b base a. Then apply the laws of log of the same base, that is log a base a is equals to 1. Let's check the solution. We are going to convert this decimal into fraction. We are going to have log 1 over 10,000 base 100. Then convert the fraction into power form, that is log 100 to power minus 2 base 100. Now let's apply these laws of logarithm where log b raised to power c base a is equals to c log b base a. We now have minus 2 log 100 base 100. Therefore, minus 2 multiplied by 1, this is the log of the same base. We are going to make it 1 is equals to 1. Minus 2 multiplied by 1 is equals to minus 2. Question 8. Simplify 27 over 64 raised to power minus 2 over 3 multiplied by square root 36 over 100. Let's check the procedure for solving. The first step here is to apply the laws of indices where a over b raised to power minus c over d equals to root d of b over a raised to power c. Then convert the answer to its lowest term. Let's check the solution. Now let's apply the laws of indices where a over b raised to power minus c over d is equals to root d of b over a raised to power c. When we apply this law for this term, we have root 3 of 64 over 27 raised to power 2 multiplied by root 36 over 100. We now have 4 over 3 square multiplied by root 36 over 100. We have 6 over 10. Here, square of 4 over 3 now, we have 16 over 9 multiplied by 6 over 10. We have 16 over 50. Question 9. A man paid 35,000 naira in 50k ordinary shares of a company sold at 70k per share. How many units of shares did he buy? Let's check the procedure for solving this. The first step here is to convert the 70 kobo into naira. That is, 70 kobo makes 1 naira. Step 2. We apply the formula for the unit of shares bought, that is, unit of shares bought is equals to amount paid over amount of shares sold per share. Let's check the solution. We convert 70 kobo to naira. We have 0.7 naira. Then we apply this formula. When you apply this formula, the amount paid is 35,000 naira over amount of shares sold per share. The amount of shares sold per share is 0.7 naira. When you divide 35,000 naira by 0.7 naira, we have 50,000. Question 10. A man invested a sum of money at 5% per annum simple interest. After 4 years, the principal amounts to 9,000 naira. Find the sum invested. Let's check the procedure for solving this. The first step is to replace our interest and principal to be x and y respectively. Then apply the formula where interest is equals to principal multiplied by time multiplied by rate over 100. Apply the formula where amount is equals to principal plus interest. Then substitute. Let's check the solution. Let interest be s and the principal be y. Interest is equals to principal multiplied by time multiplied by rate over 100. X is equals to our principal now, y multiplied by 4 multiplied by 5 over 100. When you multiply it together, we have x is equals to 20y over 100. Let this be our equation 1. Now let's apply the formula where amount is equals to principal plus interest. We have interest plus principal is equals to amount now. That is, the interest plus the principal is equals to the amount. That is, s plus y is equals to 9,000 naira. Then let's substitute equation 1 into 2. We now have 20y over 100 plus y is equals to 9,000 naira. Then multiply through by 100. We have 20y plus 100y is equals to 900,000 naira. We have 120y is equals to 900,000 naira. When you divide both sides by the coefficient of y now is equals to 75,000 naira. The sum invested is 75,000. Question 11. If set P is equals to A, B, C and set Q is equals to A, B, C, D, E and set R is equals to A, B, C, P, Q, R. Find P union Q, intercept P union R. let's check the procedure for solving this. The intersection of two or more sets as a result of a set that contains only the common element in them. The union of two or more sets is the combination of elements of the set without repetition. Then find the union of set P and set Q. Find the union of set P and set R. Find their intersection. Let's check the solution. P union Q is equals to A, B, C, D, E. The combination of what is common in set P and set Q. P union R is equals to the combination of elements in set P and set R without repetition. That is A, B, C, P, Q, R. Now let's find their intersection. The intersection of these two sets are A, B, C, D, E intersect A, B, C, P, Q, R. Now the intersection of the two sets we have, what they have in common is A, B, C. Question 12. Find the positive value of x for which 2x, 4 minus x, 3x is equals to 66. Let's check the procedure. The first step here is to find the determinant of left hand side. Determinant of 2 by 2 matrices is let A equals to A11, A12, A21 and A22 be a 2 by 2 matrix. The determinant of A denoted by this or this is a number given by determinant A equals to A11, A12, A21, A22 equals to A11 multiplied by A22 minus A12 multiplied by A21. Second step is to equate the determinant of the left hand side with the given number in the right hand side. Then rearrange the expression in terms of quadratic equation, that is ax squared plus bx plus c is equals to 0. Then use formula method to solve the quadratic equation. Let's check the solution. 2x multiplied by 3x, that is A11 multiplied by A22 minus 4 multiplied by minus x, that is A12 multiplied by A21 is equals to 66. 2x multiplied by 3x, we have 6x squared minus 4 multiplied by minus x, we have minus 4s is equals to 66. 6s squared minus multiplied by minus, we have plus, that is 6s squared plus 4s is equals to 66. Then rearrange in order of quadratic equation, that is 6s squared plus 4x minus 66 is equals to 0. Let's apply the formula method to solve the quadratic expression, where our a is equals to 6, our b is equals to plus 4 and our c is minus 66. Then substitute for the values in this formula, that is x is equals to minus 4 plus or minus square root of 4 square minus 4 multiplied by 6 multiplied by minus 66 over 2 multiplied by 6. X now is equals to minus 4 plus or minus square root of 16 plus minus 4 multiplied by minus 6 multiplied by 6. We have plus 1584 over 12. Then x is equals to minus 4 plus or minus root 1600 over 12. S is equals to minus 4 plus or minus 40 over 12. Let's separate this plus or minus. We have minus 4 plus 40 over 12 or minus 4 minus 40 over 12. We now have 36 over 12 or minus 44 over 12. Our answer now is 3 or minus 11 over 3. The positive value of s is 3. Question 13. Evaluate 11101 base 2 multiplied by 11 base 2 plus 101 base 2. Let's check the procedure. The procedure for solving this, open the brackets by multiplying the expression inside the brackets in base 2. Then add the expression together. To add numbers together, they must be in the same base. Arrange the digits of the numbers to be added in columns correspondingly. Then add in columns. If the sum succeeds the value of the base, take whatever number of times the sums exceeded the base to the next column and write down the remainder. Always start from right to left. Let's check the solution. Let's open the bracket by multiplying the expression inside the bracket in base 2. These are the terms in base 2. 11101 base 2 multiplied by 11 base 2. When we multiply these terms together, 1 multiplied by this term, we have this. This 1 multiplied by these terms, we have this. Now let's add them together. We have to apply this method of adding base. Let's arrange it in columns correspondingly. When we add these two values together, we have 10101111 base 2. Let's go back to our question. When we add 1001 base 2 to this term, we have 10110111. That is the multiplication of these terms. We have 1010111 base 2 plus 101 base 2. Let's add them together. When we add them together, we have 1011100 base 2. Question 14. The 21st term of an arithmetic progression is 36. Find its first term if its common difference is 6. Let's check the procedure for solving this. Apply the arithmetic progression formula where Tn is equals to a plus n minus 1 close the bracket d, where Tn is the given terms, a is the first term, n is the number of terms, d is the common difference. Then substitute for the given values. Let's check the solution. Let's apply the formula for arithmetic progression. Then substitute. N here is equals to 21. We don't know our first term. We have to find our first term. Our common difference is 6 and the total number of terms is 36. Now let's substitute. The total number of terms now, we have 36 is equals to a plus 21 minus 1 close the bracket 6. We have 36 is equals to a plus 21 minus 1. We have 20 close the bracket 6. Then 36 is equals to a plus 20 multiplied by 6. We have 120. When you collect the like terms, you have a equals to minus 84. Question 15. Find the value of x if 63 is equals to x mod 9. Let's check the procedure for solving this. Express the expressions in terms of mod 9. Let's check the solution. Here is our question. Now let's express 63 in terms of mod 9. That is, 63 is equivalent to 0 mod 9. 0 mod 9 is equals to x mod 9. Therefore, x is equals to 0.
Question 16. Given that m is equals to 2, 3, 1, 4 and n is equals to minus 1, 2, minus 2, minus 4. Find 2m minus n. Let's check the procedure for solving this. The first step here is to multiply the scalar by the given matrix. Then you subtract the expression. Let's check the solution. 2 is scalar in this question. To multiply this scalar by the given matrix, our given matrix here is m. You now have 2 multiplied by matrix m, which is equals to 2 multiplied by 2, we have 4, 2 multiplied by 3, we have 6, 2 multiplied by 1, we have 2, 2 multiplied by 4, we have 8. And after that, you subtract the expression. When you subtract n from 2m, you have 4 minus 1, 6 minus 2, 2 minus 2, and 8 minus 4. So you have 4 minus multiplied by minus, we have plus 1, 6 minus 2, 2 minus multiplied by minus, we have plus 2 multiplied by 2, we have 2. 8 minus multiplied by minus, we have plus 4. 4 plus 1, we have 5. 2 plus 2, we have 4. 6 minus 2, we have 4. 8 minus 4, we have 12. Therefore, our answer is 5, 4, 4, 12. Question 17. Simplify root 20 plus root 5 plus root 125. Here is the procedure for solving this. You have to expand the numbers under root using the patterns of squares 4, 9, 16, 25, 36, 49, and so on and so forth. Then apply the laws of sorts, where a root c plus b root c is equals to a plus b root c. Let's check the solution. Here is our question. Then expand the numbers under root using the patterns of squares. You now have 4 multiplied by 5. Don't forget this 4, it falls under the patterns of squares here. 4 multiplied by 5 plus root 5 plus root 125, it gives 25 multiplied by 5. Now let's separate them. We are going to have root 4 multiplied by root 5 plus root 5 plus root 25 multiplied by root 5. Root 4 gives 2, root 25 gives 5. We now have 2 multiplied by root 5, we have 2 root 5 plus root 5 plus root 25 gives 5. We now have 5 multiplied by root 5, we have 5 root 5. Then we apply the laws of sorts, where a root c plus b root c is equals to a plus b root c. Now we have these roots, the value under roots in common. We are going to have 2 plus 1 plus 5 root 5. Therefore, our answer is 8 root 5. Question 18. Find the sum of the first 20 terms of the arithmetic progression 2, 4, 6, 8. Let's check the procedure for solving this. Apply the formula for the sum of arithmetic progression equals to n over 2 into bracket 2a plus open another bracket n minus 1 close bracket d close bracket, where n is the number of terms, a is first terms, d is the common difference. Then you substitute for the given values. Let's check the solution. Let's apply the formula for the sum of arithmetic progression. Here is our formula, and our n is the number of terms. The number of terms, a is the first term, which is 2. Here is our second term, here is our third term, and here is our fourth term. D is the difference between the second term and the first term, that is 4 minus 2 equals to 2. Then let's substitute for the values. You now have 20 over 2, open the bracket, 2 into bracket of 2 plus 20 minus 1, close the bracket, 2. Sum of the first 20 terms now is equals to 10, open the bracket, 4 plus, we have 19 multiplied by 2 here, which is 38. Then you have 10 into bracket 4 plus 38, we have 42. You now have sum of the first 20 terms is equals to 10 multiplied by 42 is 420. Question 19. Factorize 16n squared minus 16n plus 4. Here is the procedure for solving this. Factorize the expression by taking out what is common. Okay, then factorize the expression inside the bracket. Let's check the solution. Here is our question. Let's factorize the expression by taking what is common out. What is common here is 4. 16n squared divided by 4, we have 4n squared. Minus 16n divided by 4, we have minus 4n. Plus 4 divided by 4, we have plus 1. Then you factorize the expression inside the bracket. For us to factorize this, we are going to have 4 into bracket 4n squared minus 2n plus 1. Let's group the terms into 2. We now have 2n in common here. We now have 2n, open the bracket, 4n squared divided by 2n, you have 2n, minus 2n divided by 2n, you have minus 1. Well, what is common here is minus 1. Minus 2n divided by minus 1, we have 2n, plus 1 divided by minus 1, we have minus 1. What is common here is 2n minus 1 is common in this expression. This term divided by the common factor, we have 2n remain. This term divided by this value, we have minus 1 remain. Question 20. If x varies directly as y and 1 over y varies directly as z, how does x varies with z? Let's check the procedure for solving this. Introduce a constant k to enable us to replace proportional to by equals to in the first expression and constant c in the second expression. Then solve for y in equation 1 and equation 2. Equate equation 4 and equation 3. Then represent constant k over c as constant b. Let's check the solution. Let's say x is equals to ky as our equation 1. And 1 over y is equals to cz as our equation 2. That is when we introduce constant to both expressions. Then let's solve for y in equation 2 and 1. In equation 1, when we divide both sides by k, we have y to be x over k. Let this be our equation 3. Let's solve for y in equation 2. When we multiply through by the LCM to clear the fraction, the LCM here is y. We have 1 is equals to czy. When you divide both sides by cz, y is equals to 1 over cz. Then equate equation 4 and 3. When you equate equation 4 and 3, we have x over k is equals to 1 over cz. Then cross multiply. When you cross multiply, we have x is equals to k over cz. X is equals to k over c, that is our constant, multiplied by 1 over z. Now let's represent k over c as constant b. We now have x is equals to b multiplied by 1 over z. Then let's convert it. We have x varies directly as 1 over z. Question 21. If y varies inversely as the square of x and y is equals to 1 over 2, when x is equals to 2, find the positive value of x when y is equals to 18. Procedure for solving this. If y varies inversely as the square of x, it means this expression. Then you introduce a constant k to enable us replace proportion to sine by equals to sine to make equation. Then substitute for the given values. Let's check the solution. Let's replace proportion to by equals to. We now have y is equals to k over x squared. Then you will substitute for the given value. What are our given values? Y is 1 over 2 when x is 2. We now have 1 over 2 is equals to k over 2 raised to power 2. That is 1 over 2 is equals to k over 4. Then we cross multiply to clear the fraction. We now have 2k is equals to 4. Then divide both sides by 2. Therefore, k is equals to 2. Then we substitute k for 2 and y for 18 in the equation. Here is our equation. Y now for 18 and k for 2. Solve for x, that is the positive value of x according to the question. The next thing here is to cross multiply. When you cross multiply, we have 18x squared equals to 2. Then divide both sides by 18. We have x squared to be 1 over 9. Then square root both sides. You now have x is equals to 1 over 3. Question 22. Make L the subject of the formula in t equals to 2 pi into bracket L over g close the bracket raised to power 1 over 3. Let's check the procedure for solving this. Take cube of both sides to remove cube roots. Cross multiply to clear the fractions. Then divide both sides by the coefficient of the unknown value. Let's check the solution. Take cube of both sides to remove cube roots. When we take cube of this, we have this expression. This 3 here cancel the 3 here. We have raised to power 1 remain. 2 raised to power 3, we have 8. Pi raised to power 3, pi raised to power 3. We now have t raised to power 3 equals to 8 pi raised to power 3l over g. That is when you multiply this term by this. Cross multiply to clear fractions. You now have t raised to power 3 multiplied by g, that is t raised to power 3g equals to 8 pi raised to power 3l multiplied by 1. You have 8 pi raised to power 3l. Then divide both sides by 8 pi raised to power 3. Therefore, we have our l to be gt raised to power 3 over 8 pi. Question 23. Given the relation y is equals to qx plus 3 for every values of x and y in the table below. Here is the table. Find the value of q for any corresponding values of x and y. Let's check the procedure. The value of y and x is given in the table. Then substitute for y and x, where y is equals to minus 3 and x is equals to minus 3 in the given expression. Then collect the like terms. Then divide both sides by the coefficient of the unknown number. Let's check the solution. Let's substitute for y to be minus 3 and our x to be minus 3. You can also use y to be minus 1 and x to be minus 2. Or you use y to be 5 and x to be 1. You will arrive to the same answer. The value of y and x in the given table, then substitute for y and x, where y is equals to minus 3 and x is equals to minus 3 in the given expression. Minus 3 is equals to q into bracket minus 3 plus 3. That is when you substitute for your y to be minus 3 and your x to be minus 3. You have this expression. Minus 3 is equals to minus 3 multiplied by q. You have minus 3q plus 3. Then collect the like terms. When you collect the like terms, you have minus 6 is equals to minus 3q. Then divide both sides by minus 3. We have q to be 2. Question 24. Solve the equation 1 over x minus 5 over 3x is equals to 5 over 6. Here is the procedure for solving this. Multiply through by the LCM to clear fractions. Then divide both sides by the coefficient of the unknown number. Let's check the solution. The first step here is to multiply through by the LCM to clear the fraction. The LCM of the denominator is 6x. Let's multiply through by 6x. We have this expression, that is 6x multiplied by 1 over x minus 6x multiplied by 5 over 3x is equals to 6x multiplied by 5 over 6. That is, we have to multiply each term by 6x. We have 6x multiplied by 1, we have 6x over x. 6x multiplied by 5, we have 30x over 3x is equals to 6x multiplied by 5, we have 30x over 6. 6x divided by x, we have 6, minus 30x divided by 3x, we have minus 10, equals to 30x divided by 6, we have 5x. 6 minus 10, we have minus 4, equals to 5x. Then divide both sides by 5. X is equals to minus 4 over 5. Question 25. Find the values of x and y. If x plus 3y is equals to 2x plus y and 8 minus y is equals to 8 plus y. Let's check the procedure for solving this. Here we are going to apply elimination by equating method, where in each equation get an algebraic value of the same unknown quantity. Solve for x in equation 1 and equation 2. Then equate the algebraic values to form simple equation. Equate equation 1 and equation 2. Step C is to solve for the unknown value. Step D, substitute the value of the unknown from any of the algebraic values and solve for the other unknown. Let's check the solution here. Let's represent this to be our equation 1 and this to be our equation 2. Here we are going to use elimination by equating method. Here we are going to solve for x in equation 1 and 2. For us to solve for x in equation 1, we are going to collect like terms in equation 1. We now have 3y minus y is equals to 2x minus x. 3y minus y, we have 2y is equals to 2x minus x, we have x. Therefore, x is equals to 2y in equation 1. Let's solve for x in equation 2. For us to solve for x in equation 2, we need to collect the like terms. We now have 8 minus y is equals to x. 8 minus 2y is equals to x. Therefore, x is equals to 8 minus 2y in equation 2. The next step is to equate the algebraic values to form simple equation. Equate equation 1 and equation 2. Here is our equation 1. We have 2y as our equation 1 and 8 minus 2y to be x in our equation 2. Now let's equate them. We now have 2y is equals to 8 minus 2y. Let's collect like terms. We have 2y plus 2y equals to 8. 4y is equals to 8. Then divide both sides by 4. We have y to be 2. Y is equals to 2. Next step is to substitute the value of the unknown from any of the algebraic values and solve for the other unknown. Now let's substitute y for 2 in equation 1. We now have x is equals to 2y. Let's substitute for y. We now have x is equals to 2 multiplied by 2. X is equals to... Question 26. Let y to be every great city was not built in a day, and Z to be Kano is a great city. Which of the following statements is true? Let's check the procedure for solving this. Represent the implications in form of Venn diagram, then interpret the implication. Here is a Venn diagram. The big circle here represents every great city, while the small circle represents Kano. That is, Kano is inside every great city. Let's check the solution. Now let's interpret the implication. The interpretation of the implications is Kano was not built in a day, because Kano is inside every great city and every great city was not built in a day. Therefore, Kano is a great city and every great city was not built in a day. Therefore, Kano was not built in a day. Question 27. Let P be Ade is lazy and Q be he fails the examination. Write the following statement in symbolic form. His failure in the examination is due to his laziness. Let's check the procedure for solving this. Interpret the implication, then write the statement in symbolic form. Let's check the solution. This implication is P implies Q. Ade is lazy and due to his laziness, he failed. Therefore, P implies Q. That is, Ade is lazy implies he fails his examination. According to this statement, we have his failure in the examination is due to his failures. This statement is the converse of this implication. The converse of P implies Q is Q implies P. Therefore, the symbolic form of the statement is Q implies. Question 28. Which of the following pairs of inequalities is represented on the number line below? Here is our number line. Let's check the procedure for solving this. This type of dot is known as open dot. And open dot is used to represent strict inequalities, that is, less than or greater than. While this dot is called thick dot, it represents weak inequality, that is, less than equals to or greater than equals to. Let's check the solution. If the line is facing right hand direction, that means inequality is greater than, but if it is facing the left direction, it's less than. Don't forget that dot here is thick dot. The other dot here is thick dot as well. Therefore, we are going to have less than equals to here because it is thick and it faces the left hand side. Here it is thick and it faces the right hand side. Therefore, we are going to say P is less than equals to minus 2. This is where it starts. And P is greater than equals to 1. This is where it starts. Therefore, P is less than equals to minus 2 and P is greater than equals to 1. Question 29. Simplify 3 minus A over A plus 3B. Let's check the procedure for solving this. Find the LCM of the denominator. That's step 1. Then make the expression a single fraction. Let's check the solution. The LCM is A plus 3B. For us to make this expression a single fraction, we are going to say A plus 3B multiplied by 3. we have 3 into bracket a plus 3b. When you divide this denominator by the LCM, you have 1 multiplied by a, we have a. Let's collect the like terms. We now have 3a minus a plus 9b. 3a minus a, we have 2a plus 9b over a plus 3b. Question 30. Find a quadratic equation whose roots are 2 over 3 and minus 9. Here is the procedure for solving this. Let x be our variable, then make x equals to the roots. Cross multiply to clear fractions, collect the like terms and group the expression, then expand the expression. Let's check the solution. Let x be our variable, that is the unknown value. X now is equals to, according to the step 2, is equals to the roots, equals to 2 over 3, or x is equals to minus 9. Let's cross multiply for this first value to clear the fraction. We now have 3x is equals to 2, or x is equals to minus 9. When you collect the like terms, we have x plus 9 equals to 0. Here we have 3x minus 2 equals to 0. Now let's group them. We now have 3x minus 2, x plus 9 equals to 0. When we expand the expression, we have 3x, this value multiplied by this term, and this value multiplied by this term equals to 0. Now 3x multiplied by x, we have 3x squared, plus 3x multiplied by 9, we have 27x, minus 2 multiplied by x, we have minus 2x, minus 2 multiplied by plus 9, we have minus 18 equals to 0. 3x squared plus 27x minus 2x, we have 25x minus 18. Question 31. Simplify 1 over x minus 3y minus 2 over x plus 4y. Let's check the procedure for solving this. Find the LCM and simplify the expression by making the expression a single fraction. Let's check the solution. The LCM of the denominator is x minus 3y and x plus 4y. For us to make this expression a single fraction, we are going to say LCM divided by the denominator of this term. We have x plus 4y, and x plus 4y multiplied by 1. We have 1 multiplied by x plus 4y. LCM divided by the denominator of this term, we have x minus 3y. Therefore, we have minus 2 into bracket x minus 3y over LCM. Open the bracket for the numerator. 1 multiplied by x, we have x. 1 multiplied by 4y, we have 4y. Minus 2 multiplied by x, we have minus 2x. Minus 2 multiplied by minus 3y, we have plus 6y. Let's collect the like terms. We now have 4y plus 6y plus x minus 2x over the LCM. 4y plus 6y, we have 10y, plus x minus 2x, we have minus x. Therefore, answer is 10y minus x over x minus 3y into bracket x plus 4y into bracket. 32. Evaluate xy plus 1 over 2 a square y when x is equals to minus 20, y is equals to 3, and a is equals to 4. Let's check the procedure for solving this. Substitute for the given values in the expression. Let's check the solution. You have to substitute for the known values in the given expression. They have given us the value for x, and the value for y, and the value for a. Here we are going to substitute. You now have minus 20 multiplied by 3, that is x multiplied by y, plus 1 over 2 multiplied by 4 squared, that is a squared, multiplied by 3, 3 represents y. Minus 20 multiplied by 3, we have minus 60 plus 1 over 2, 4 squared gives 16. When you multiply this together, you have minus 60 plus 1 over 2, 16 multiplied by 3, we have 48. Minus 60 plus 48 multiplied by 1, we have 48 over 2. Minus 60 plus 48 divided by 2, you have 24. Minus 60 plus 24 minus 36. Question 33. Given that an is equals to 3n raised to power 3 plus 5n raised to power 2 minus 27 all over n, evaluate a3 plus a2 correct to the nearest whole number. Let's check the procedure for solving this. Solve for a3 by substituting 3 for n, and solve for a2 by substituting 2 for n in the given expression, then round up to the nearest whole number. Let's check the solution. The first step is to solve for a3 by substituting 3 for n. We are going to have this expression. 3 raised to power 3, we have 27. 3 squared, we have 9. Let's open the brackets. 3 multiplied by 27, we have 81, plus 5 multiplied by 9, we have 45, minus 27 over 3. A3 now is equals to 99 over 3. A3 is equals to 33. Now let's solve for 2 by substituting 2 for n in the given expression. A2 is equals to 2 raised to power 3, we have 8. 2 raised to power 2, we have 4. When you open the bracket, 3 multiplied by 8, we have 24. 5 multiplied by 4, we have 20, minus 27 over 2. A squared is equal to 24 plus 20 minus 27 over 2 equals to 17 over 2. A3 plus A2 is equals to 33 plus 8.5, that is 17 divided by 2. When you add it together, you have 41.5. When you approximate it to the nearest whole number, we have 42. Question 34. Find the acute angle between lines whose slopes are 2 and 1 over 3. Here is the procedure for solving this. The angle between two intersecting lines with slope m1 and m2 is given by theta is equals to arctan into bracket m2 minus m1 over 1 plus m2 multiplied by m1. We represent m2 to be 1 over 3 and m1 to be 2. Then substitute. Let's check the solution. Theta is equals to arctan into bracket m2 minus m1 over 1 plus m2 multiplied by m1. Let's substitute. Theta is equals to arctan into bracket 2 minus 1 over 3 over 1 plus 2 multiplied by 1 over 3. Theta is equals to arctan 2 minus 1 over 3 over 1 plus 2 multiplied by 1, we have 2 over 3. Theta is equals to arctan. The LCM of the numerator here is 3. Let's make it a single fraction. We now have 3 multiplied by 2, 6 minus 1 over 3 over the LCM of the denominator, we have 3. 3 multiplied by 1, we have 3 plus 2 over 3. Theta is equals to arctan 5 over 3 over 5 over 3. Theta is equals to arctan 5 over 3 divided by 5 over 3. Theta is equals to arctan 5 over 3 multiplied by 3 over 5. We need to change this division sign to multiplication by inverting this value. Theta is equals to arctan 1. 5 multiplied by 3 over 5 multiplied by 3. This is 15 over 15 equals to 1. Theta is equals to arctan 1. Arctan 1 is equals to 45 degree. Therefore, theta is equals to 45 degree. Question 35. Find the value of a sphere with radius 7 cm to the nearest whole number. Take pi equals to 22 over 7. The procedure for solving this: apply the formula of the volume of a sphere, 4 over 3 pi r raised to power 3. Then substitute for the given terms. Let's check the solution. Let's apply the formula for the volume of a sphere, where r represents radius. 4 over 3 multiplied by pi, that is 22 over 7, multiplied by our radius is 7. We have 7 raised to power 3. We now have 4 over 3 multiplied by 22 over 7 multiplied by 7 raised to power 3 is 343. When you multiply the numerator together, we have 30184 over 3 multiplied by 7, which is 21. When you divide it, we have 1437 cm. Question 36. An aeroplane flies from a tank latitude 47 degree north, 23 degree east, to another town L latitude 47 degree north, 57 degree west. Find the distance between K and L along the parallel of latitude to the nearest kilometer. Take R equals to 6,400 km and pi equals to 22 over 7. Let's check the procedure for solving this. The first step is to sketch a diagram. Here is the diagram. Draw a big circle. After the circle, they said an aeroplane flies from a tank that is latitude of 47 degree north. That is this. Latitude of what? 47 degree north and 23 degree east. 23 degree east. That is the longitude. And tan L 47 degree north. This is it. That is tan K and tan L are on the same latitude. And 57 degree west. This is it. That is the longitude. It falls to west. Where longitude intersects with the latitude will be our point. That is where longitude of K intersects the latitude of K will be point K, as well as L. This is our point L, this is our point K. They now say we have to find the distance between K and L along their parallel of latitude to the nearest kilometer. Then we apply the formula for distance equals to theta over 360 degree multiplied by 2 pi small r, where small r is equals to big R cos alpha. Let's check the solution. Let's apply the formula for distance. Here is the formula. That is theta over 360 degree multiplied by 2 pi big R cos alpha. Theta is the angular distance between K and L. The angular distance between K and L is 80 degree. That is 57 degree plus 23 degree, because they are on different hemisphere. If they are on the same hemisphere now, we are going to subtract it. but because they are on different hemisphere, we are going to add 57 degree plus 23 degree. We have 80 degree. And about this alpha is the given latitude. Let's multiply it together, because 47 degrees equals to 0.6820. When you multiply all the numerator together, we have 15364096 over, when you multiply all the denominator, you have 2520. When you divide the numerator by the denominator, you have 2096.863492. When you convert it to the nearest kilometer, you have 6097. Question 37. Find the gradient of the line joining the points 2, 5 and -2, -3. The procedure for solving this: gradient is given by changing y over changing x equals to y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are the coordinates of the 2 points forming the line. Therefore, x1 is equals to 2, y1 is equals to 5, x2 is equals to -2, y2 is equals to -3. Then substitute. Let's check the solution. -3 minus 5 over -2 -2. -3 minus 5 gives -8 over -2 gives -4. When you divide -8 by -4, we have question 38. The size of angle AOC in the figure above is, let's check the procedure for solving this. You have to use protractor to measure angle AOC. Angle AOC is an obtuse angle. You can see this is an obtuse angle, that is, it is greater than 90. But if you use your protractor, it's going to give you 120 degree. If you measure it very well, angle AOC is 120 degree. The solution now: angle AOC is equals to 120 degree. Question 39. Find the value of k in the diagram above. Let's check the procedure for solving this. Represent the necessary angles, then produce another parallel line to split angle 312, that is this angle. Let's check the solution. When we produce a parallel line to split this angle 312, we have this line. We have this angle as A and this angle as angle B. Then don't forget that sum of angles on the straight line is 180 degree. Therefore, we have our A to be 180 degree and B will be the remaining. That is, when you deduct 180 from 312 degree, we have B. B now is equals to 312 minus 180 equals to 132, because the sum of these two angles makes 312 degree. K is equals to B equals to 132 degree because they correspond and corresponding angles are equal. Therefore, K is equals to 132 degree. Question 40. In the figure below, PQ and PR are tangents from P to the circle with center O. If angle QPR is equals to 34 degree, find the angle marked S. Here's a diagram. Let's check the procedure for solving this. Here's our diagram. The first step here is to apply the theorem, where if two tangents are drawn from a point outside the circle, the two tangents are equal in length. Angle OQP is equals to angle POR is equals to 90 degree, that is, radius in perpendicular to tangents. Angle POQ plus angle OQP plus angle OPQ is equals to 180 degree, that is, sum of angles in the triangle is 180 degree. X is equals to 2 multiplied by angle POQ. Split this diagram into two, because this line and this line are equal. When we separate it into two, we have 17 degree here and 17 degree here. It makes 34 degree. Let's check the solution. Angle POQ plus angle OQP plus angle OPQ is equal to 180 degree. That is, sum of angles in the triangle is 180 degree. This angle R and angle Q is 90 degree. They are equal because the radius is perpendicular to tangent. Therefore, this angle and this angle are equal. They are 90 degrees. We now have angle OPQ, that is this angle, plus angle Q plus this angle to be 180 degree because they are angles in the triangle. Then we collect like terms. We now have angle POQ, that is this angle, to be 180 degree minus 90 degree minus 17 degree equals to 78 degree. Thus, X is equals to 2 multiplied by angle POQ, that is, this angle is equals to POQ. 2 multiplied by POQ, you now have 2 multiplied by 78 degree. X is equals to 146 degree. Or you say, since this angle is 78 degree, and you know that these two angles are equal, when you have 78 degree here, we also have 78 degree here. Therefore, the sum of these two angles now is 146 degrees. Question 41. Calculate the value of x in the figure below. That is, in this diagram, here is angle x, here is 92 degrees. Let's check the procedure for solving this. Let's represent the necessary angles. Here we make use of A and B. Let's represent this angle to be our A and this angle to be angle B. We have A plus 92 degrees, that is this angle plus this angle to be 180 degrees, that is sum of angles on a straight line, and this angle to be our B, that is B plus A to be 180 degrees. Sum of opposites cyclic quadrilateral is 180 degrees. B plus X is equals to 180 degrees, that is sum of angles on a straight line is 180 degrees. Here is the diagram. Let's check the solution. A plus 92 is equals to 180 degrees, that says the sum of angles on a straight line. We represent this angle to be our A and this to be our B. The sum of angles on a straight line, this straight line, A and 92 degrees are on a straight line. Therefore, the sum of these two angles is 180 degrees. For us to get our A, we need to collect like terms, and we have A is equals to 180 minus 92 is equals to 88 degrees. You now say B plus A is equals to 180 degrees. That is the sum of opposite cyclic quadrilateral is 180 degrees. These angles, the sum of these two angles are 180 degrees. We now have B plus, when you substitute for your A, which is 88 degrees, we have 88 is equal to 180 degrees, then collect the like terms. B is equals to 180 minus 88 equals to 92 degrees. For us to get our S, we can see that B and S are on a straight line, and for us to get our X, we need to apply the sum of angles on a straight line. That is, the sum of these two angles are 180 degrees. We now have B plus X is equals to 180 degrees. When we substitute 92 for B, we have 92 plus X is equals to 180 degrees. When you collect like terms, we have X is equals to 180 minus 92 equals to 88 degrees. Question 42. Find the value of X in the diagram below. Here is the diagram. For you to get the value of X, let's check the procedure for solving this. Represent the necessary angles with letters. Let's represent all the angles with letters. Here is our A, here is our B, here is our D, here is our C. A is equals to 42 degrees. This angle and this angle are isosceles angles, and isosceles angles are equal. Here is isosceles line, and we call this triangle an isosceles triangle. Now we have A is equals to 42 degrees, and A plus D plus 42 is equals to 180 degrees. That is, sum of the angles in a triangle is 180 degrees. D is equals to C. Vertically opposite angles are equal, and C plus X plus B is equals to 180 degrees. That is, the sum of this triangle is 180 degrees. B is equals to X because they are isosceles, and isosceles angles are equal. Let's check the solution. Here is the diagram. A is equals to 42 degrees. Isosceles triangles are equal. A now is equals to 42 degrees. The sum of these angles is 180 degrees. We now have A plus D plus 42 degrees is equals to 180 degrees. Substitute A for 42 and collect the like terms. We have D is equals to 180 minus 42 is equals to 96. D is equals to C equals to 96 degrees. That is, D is equals to C. Vertically opposite angles are equal. This also is an isosceles triangle. We now have C plus X plus B is equals to 180 degrees. Sum of angles in the triangle. B is equals to S. Isosceles angles are equal. Because angle and this angle are isosceles angles, now let's substitute C for 96, then collect the like terms. We have C plus B plus B. Because X is equals to B, we now represent S as B. We now have C plus B is equals to 180 degrees. Let's collect like terms. 2B is equals to 180 minus 96. When we substitute for C, we have 96. Then 2b is equals to 84. When you divide both sides by 2, we have b is equals to 42. They said we have to find x, and b is equals to x. X is equals to b. That is, x is equals to 42 degrees. Isosceles angles are equal. Question 43. Calculate the volume of a cylinder cone of base radius 3 cm and perpendicular height 7 cm. Take pi equals to 22 over 7. Let's check the procedure for solving this. Apply the formula for the volume of cone. Volume is equals to 1 over 3 pi r square h. Then substitute for the given terms. Let's check the solution. Let's apply the formula for the volume of cone. Then substitute. Let's substitute for the given terms. we have 1 over 3 multiplied by 22 over 7 multiplied by 3 square, that is radius square. Here is our radius, multiplied by height, which is 7. When you multiply the numerator together, we have 1386. When you multiply the denominator together, we have 21. When you divide numerator by denominator, we have 66 centimeters. Question 44. Find the coordinates of the midpoint of the line joining A 5, 2 and B 3, 4. Let's check the procedure for solving this. The midpoint of AB has coordinates x1 plus x2 over 2 and y1 plus y2 over 2, where s1 is equals to 5, y1 is equals to 2, s2 is equals to 3, and y2 is equals to 4. Then substitute. Let's check the solution. Here is the formula for the midpoint. Then let's substitute. We now have 5 plus 3 over 2 and 2 plus 4 over 2. We have 8 over 2 and 6 over 2. 8 divided by 2 we have 4, 6 divided by 2 we have 3. Question 45. Find the value of y in the figure below. Here is the diagram. We have to find the value of y. Here is the procedure for solving this. Represent each angle with capital letters and each side with the small letters of opposite angles. Then apply cosine rule, where y square is equal to x square plus z square minus 2xz cos capital letter Y. Condition for applying cosine rule: 1. Given two sides and the included angle. Condition 2. Given all the three sides of the triangle. Here is the diagram. We have to represent each angle. We represent it as capital letter Y, capital letter Z, and capital letter X. We represent each side as the small letters of the opposite angles. Now, small letter of X is this, small letter of Z is this, and small letter of Y is this. Now, let's check the solution. Is this capital letter Y will represent our angles, and the small letters will represent our sides. For us to get Y, that is small letter Y, which is the side, we are going to apply this formula. Then let's substitute. We have y square is equals to 5 square plus 12 square minus 2 multiplied by 5 multiplied by 12 cos 84 degrees. Y square now is equals to 5 square is 25 and 12 square is 144 minus 2 multiplied by 5 multiplied by 12 is 120 cos 84 degrees. Cos 84 degrees is 0.1045. Y square is equals to 25 plus 144. 120 multiplied by 0.1045. We have 12.54. Y square now is equals to 156.46. Then square root both sides. When you square root both sides, y is equals to 12.50839718 centimeter. When you approximate it to the nearest two decimal places, we have 12.51. Question 46. In triangle XYZ, capital letter X is equals to 110 degree, small letter x is equals to 15 centimeter, small letter y is equals to 10 centimeter. Find angle XYZ. Let's check the procedure for solving this. The first step here is to sketch a triangle diagram. Second step is to represent each angle with capital letters and each side with the small letters of opposite angles. That is something like this. We represent this as our y, this as our x, this as our small letter x, this as our capital letter z, this as our small letter y, and this as our small letter z. Then apply sine rule. Small letter a over sine capital letter A is equals to small letter b over sine capital letter B equals to small letter c over sine capital letter C. Let's check the solution. Here we are given angle x and we are given the side of the angle. Let's make use of small letter x over sine capital letter x is equals to small letter y over sine capital letter y. Since we are told to find angle y, so we are going to make use of x, that is the one that have angle and side. Let's represent. Small letter x is 15, angle s is 110 degree equals to small letter y is equals to 10 centimeter. And we don't know angle y, therefore we need to solve for our angle y. The next thing here is to cross multiply to clear the fractions. 10 multiplied by sine y is equals to 10 multiplied by sine 110. Sine 110 is 0.939692628. When you multiply 10 by this, you have 9.396926208. Then divide both sides by 15. you have sine y equals to 0.6264617472. The arcsine of this value is 38.78955,642. When you approximate it to the nearest two decimal places, we have 38.79 degree. Tan A is 40 km due west of tan C, and tan B is 50 km due south of C. Given that the bearing of B from A is 141 degree, use this information to answer questions 47 and 48. Question 47. What is the bearing of A from B? Let's check the procedure for solving this. The first step is to sketch the required diagram. If a bearing of a point A is described from another point B, then the bearing of B can be described from A based on description. Then represent the necessary angles in terms of letters and find the value of the represented angles. Then calculate the angles in bearing B in clockwise form, starting from north till you reach the line that heads to bearing A. Here is the required diagram. Tan A is 40 km due west of tan C. We have our tan B here and our tan A here. Given that the bearing of B from A is 141 degree, from A you have to start from the north. We have from this north to this east, we have 90 degree. Don't forget we are going to 144 degree. And 144 degree does not up to 180 degree. 144 degree is in the range of 90 to 180 degree. We can see that we represent our required angle. This is 90 degree because it's a right angle. The remaining is 51 degree because once you deduct 90 degree from 141 degree, you have 51 degree, and the remaining 51 degree will be your x. Now we represent this as our y and this as our z. Let's check the solution. According to the question, they said what is the bearing of A from B? That is, from B, we need to calculate from the north to the line that join bearing A. We know that W plus S gives 141 degree. W is equals to 90 degree, that is right angle is 90 degree. 90 plus S is equals to 141 degree. When you collect like terms, we have X is equals to 141 minus 90 equals to 51 degree. Y plus Z is equals to 90 degree, that is right angle is 90 degree. Y plus Z. X is equals to Z equals to 51 degree, that is alternate angles are equal. Y plus Z now is equals to 90 degree. When you substitute for your Z, you have 51 degree. Y plus 51 is equals to 90 degree. When you collect like terms, you have Y is equals to 39 degree. Here is the diagram. We have Z to be 51 degree. We have our Y to be 39 degree because the sum of 39 and 51 degree is the right angle. Now they said we have to find the bearing of A from B. That is, we have to start calculating from the North Pole here to the line joining point B to point A. We have to start counting from here. We know that this is right angle, we have 90 degree here. This is another right angle, we have 90 degree. This is another right angle, we have another 90 degree, making 270 degree. And from here to this line that join bearing A, we have 51 degree. So therefore, the sum of these angles is the bearing of A from B. That is, the bearing of A from B is 90 plus 90 plus 90 degree plus 51 degree is equals to 321 degree. Question 48. Find the distance AB to the nearest kilometer. Here is the procedure for solving this. Apply sine rule to find the distance AB, where small letter A over sine capital letter A is equals to small letter B over sine capital letter B equals to small letter C over sine capital letter C. Here is the diagram. We've calculated this in our previous question. Here is 90 degree right angle and the remaining is 51 degree because here to here is 141 degree, and we have this as right angle 90 degree. Here is 51 degree. This is alternate to this. And the remaining here is 39 degree because this is a right angle as well, and the sum of these two is 90 degree. We have 51 degree, 90 degree and 39 degree. And for us to get distance AB, we need to apply sine rule. We are given capital letter B and small letter b, and for us to get this line AB represents small letter C. Therefore, we are going to apply sine rule of small a over sine capital letter A is equals to small c over sine capital letter C. Then let's substitute. We have 50 km over sine 51 degree equals to c over sine 90 degree. Then multiply it to clear fractions. C multiplied by sine 51 degree is equals to 50 multiplied by sine 90 degree. Sine 51 degree is 0.7772, so sine 90 degree is 1. When you divide both sides by 0.7772, we have C equals to 64.33350,489. When you round it up to the nearest kilometer, we have 64 kilometer. Therefore, C is equal to. Question 49. Find the range of the following set of marks. Here is the procedure for solving this. Range is equal to highest score minus lowest score. Let's check the solution. Highest score in this set of marks is 80 and lowest score in this set of marks is 35. Then highest score minus lowest score is 80 minus 35 equals. Question 50. Calculate the standard deviation of the following data: 43 kg, 39 kg, 42 kg, and 40 kg. Let's check the procedure for solving this. Find the mean. Mean is equal to summation x over n. Then prepare a table for x, x minus mean, and x minus mean square. Then apply standard deviation formula. If the data have a frequency of 1 each, we use this formula. If they have other frequencies, or if the data are grouped, we use this formula. Let's check the solution now. The first thing here is to find the mean. The summation of x, that is the sum of the mark, is 164 over the numbers of scores given. We have 4. When you divide 164 by 4, we have 41. Second step here is to prepare a table for x, x minus mean, and x minus mean square. Here is x, here is our scores. X minus mean now, we have x is 43 minus mean, which is 41, we have 2. X here is 39 minus mean is minus 2, we have x here to be 42 minus mean, which is 41, we have 1. We have x here to be 40 minus mean, which is 41, we have minus 1. The square of x minus mean square. Now the square of 2 is 4, square of minus 2 is 4, square of 1 is 1, square of minus 1 is 1. The summation is equal to 10, that is 4 plus 4 plus 1 plus 1 is equal to 10. Standard deviation is equal to square root of summation x minus mean square over n. Therefore, standard deviation is equal to square root of 10 over 4 equals to 2.5. Square root of 2.5 is equal to 1.58113883. When you approximate it to nearest one decimal place, we have 1. Question 51. Find the variance of 4m, 4m minus 1, and 4m plus 1. Let's check the procedure for solving this. Find the mean. Mean is equal to summation x over n. Then prepare a table for x, x minus mean, and x minus mean square. Then apply the formula for variance, where variance is equal to summation x minus mean square over n. Let's check the solution. N means number of scores, and the number of scores here are 3. This is the formula for mean. Summation x is 4m plus 4m minus 1 plus 4m plus 1 divided by n, which is 3. Let's collect like terms. We have 4m plus 4m plus 4m minus 1 plus 1 over 3. 4m plus 4m plus 4m is equals to 12m divided by 3 is equals to 12m divided by 3 is equals to 4m. Therefore, our mean is equals to 4m. The second step is to prepare a table for x, x minus mean, and x minus mean square. Here is our x. Here is our x minus mean. X minus mean now is here is our x. X minus mean, that is 4m minus 4m. 4m minus 1 minus 4m equals to minus 1. When you open the bracket and subtract minus 4m, you have minus 1 left. Here we have 4m plus 1 as our x, minus mean minus 4m. We have 4m plus 1 minus 4m. When you collect the like terms, you have plus 1. X minus mean square. 0 square is 0. Minus 1 square is 1. 1 square is 1. The summation of x minus mean square is equals to 2. Now let's apply the formula for variance. Summation x minus mean square over n is equals to 2 over 3. Question 52. Two dice are thrown together at the same time. Find the probability of getting a total score divisible by 3. Let's check the procedure. Probability is equal to number of expected outcome over total number of possibility outcome. Then prepare sample space. Then pick out the scores divisible by 3. The sample space is this. Let's check the solution. Probability is equal to number of expected outcome over total number of possibility outcome. The total score divisible by 3 are 3, 3, 6, 6, 6, 6, 6, 9, 9, 9, 9, and 12. Divided by the total number of possibility outcomes are 36. If you count this one now, we have 12 over 36. When you convert it to its lowest terms, we have 1 over. Question 53. A 3-digit number is formed by arranging 2, 3, and 5 in a random order. Find the probability that the number is divisible by 5. Let's check the procedure for solving this. The 3-digit number formed by arranging 2, 3, and 5 are 235, 253, 325, 532, and 523. The formula for probability is equal to number of expected outcome over total number of possibility outcome. Let's check the solution. The probability of number divisible by 5 is equal to 235 and 325. The total number of possibility outcomes are 235, 253, 325, 352, 532, and 523. Now, the total number of expected outcome over total number of possibility outcomes is 2 over 6. When you convert it to its lowest term, you have 1. Question 54. An agricultural firm engaged casual workers in their farm. The cumulative curve below shows their average earnings per hour. Use the graph to answer questions 54 to 56. Question 54. Find the median of the curve. Let's check the procedure for solving this. Total frequency is 50. Apply the formula for median, where median is equal to 50 over 100 of cumulative frequency. Find the value of cumulative of 1 over 2 of cumulative frequency from the ogive. Then draw a line horizontally to call the curve, then trace vertically down to the class axis to get the median. Let's check the solution. Median is equal to 50 over 100 of cumulative frequency. Median is equal to 1 over 2 of cumulative frequency. Median is equal to 1 over 2 multiplied by 50. Median is equal to 1 over 2 multiplied by 50. Median is equal to 25th mark. The value at cumulative of the 25th mark from the ogive is 16.5. Median is 16.5. Now let's check. From here now, median, the 25th mark, let's check the value at cumulative of 25th mark from the ogive. You are to draw a line horizontally to call the curve. We are to check for 25th mark. Here is 10, here is 20, here is 30. From here, that is 25th is in the range of 20th to 30th. Here is 20, here is 21, 22, 23, 24, 25. Therefore, we are going to trace the line horizontally to cut the curve. Let's trace it vertically down to the class axis to get our mean. We have 14.5 here, 15, 15.5, 16, here is 16.5. Therefore, our median is equal to 16.5. Question 55. Evaluate the 7th deciles. Here is the procedure for solving this. The total frequency is 50. Then apply the formula for 7th deciles, where 7th deciles is equal to 7 over 10 of cumulative frequency. Then find the value at cumulative of the 7th over 10 of cumulative frequency from the ogive. Draw a line horizontally to call the curve, then trace vertically down to the class axis to get the 7th deciles. Let's check the solution. 7th deciles is equal to 7 over 10 of cumulative frequency. Now 7th deciles is equal to 7 over 10 multiplied by 50 is equal to 35th mark. Let's draw a line horizontally to call the curve. Here is 25th mark. Now let's trace our 25th mark now. Here is 10, here is 20, here is 30. Don't forget that 35 is in the range of 40 and 30. Now let's trace it. Here is 30, here is 31, here is 32, here is 33, here is 34, and here is 35. We need to draw a line horizontally to call the curve. Here is it. Now let's trace it vertically down to the class axis to get the 7th deciles. When we trace it vertically, we have here is 19.5, here will be 20. Therefore, the value at cumulative of the 35th mark from the ogive is 20. Question 56. Find the 40th percentile to the nearest whole number. Here is the procedure for solving this. Total frequency is 50. Then apply the formula for 40th percentile. 40th percentile is equal to 40 over 100 of cumulative frequency. Then find the value at cumulative of the 40 over 100 mark from the OGIF. Draw a line horizontally to cut the curve, then trace vertically down to the class axis to get the 40th percentile. Let's check the solution. 40th percentile is equal to 40 over 100 of cumulative frequency, that is 40 over 100 multiplied by the level of cumulative frequency, that is 50. The 40th percentile is equal to 20th mark. Let's trace to the 20th mark. Here is our 10, here is our 20th. We are going to draw a line horizontally to cut the curve. Then trace vertically down to the class axis. We have 14.5 here, here will be 15. The value at cumulative of the 20th mark from the OGIF is 15. Therefore, 40th percentile is equal to 15. Question 57. A box contains 3 blue, 2 green, and 4 red identical balls. If 2 balls are selected at random without replacement, find the probability that the 2 balls are of the same color. Procedure for solving this. This can happen if either the 2 balls are either blue or green or red, that is blue, blue, or green, green, or red, red. Probability is equal to number of expected outcome over total number of possibility outcome. In the first selection, total balls and the number will not be affected, but the second selection will reduce by 1 as a result of non-replacement of the first selection. Therefore, probability of 2 balls are of the same color is equal to probability of blue multiplied by blue, that is the one that has reduced by 1, plus probability of green multiplied by green of non-replacement, plus probability of red multiplied by probability of non-replacement. Let's check the solution. Probability of blue here is 3 over 9. When choose at random without replacement, 3 will reduce by 1, 9 will also reduce by 1. We have 2 over 8. Plus probability of green, that is 2 over 9, multiplied by green selected at random without replacement. 1 will reduce from here, 1 will also reduce from 9. We have 1 over 8. Plus probability of red, that is 4 over 9, multiplied by probability of red not replaced, that is 4 minus 1, which is 3, over 9 minus 1, 8. 3 multiplied by 2 is 6, over 9 multiplied by 8, we have 72, plus 2 multiplied by 1, we have 2, over 9 multiplied by 8, we have 72, plus 4 multiplied by 3, we have 12, over 9 multiplied by 8, we have 72, is equal to, when you find the LCM, LCM is 72, when you add the numerator together, we have 20 over 72. Question 58. Find the derivative of y equals to 3x minus 1 raised to power minus 2 with respect to x. Here is the procedure for solving this. Here, y is a function of x. We are going to apply chain rule. That is, dy over dx is equal to dy over du multiplied by du over dx. Then apply general rule to find your dy over du and du over dx. The general rule is y is equal to ax raised to power n. Then dy over du is equal to n multiplied by ax raised to power n minus 1, and du over dx is equal to n multiplied by ax raised to power n minus 1, where a and n are any constants. That is, multiply the coefficient of x by the power n and reduce the power of x by 1. Let's check the solution. Apply chain rule. Here is the chain rule. Here is the question. U is 3x minus 1. Y will be u raised to power minus 2. Let's apply general rule to find our du over dx. We are going to have n multiplied by ax raised to power n minus 1. N is 1 multiplied by minus 2, that is a raised to power minus 2 minus 1. N is minus 2, that is the given power, equals to minus 2 multiplied by 1, we have minus 2u, minus 2 minus 1, we have minus 3. The u over the x is equals to 3 multiplied by 1x raised to power 1 minus 1 equals to 3 multiplied by 1, we have 3, x raised to power 1 minus 1, we have 0 equals to 3 multiplied by anything raised to power 0 is 1. We have 3 multiplied by 1 equals to 3. dy over dx is equals to dy over du multiplied by du over dx. Therefore, dy over dx is equals to minus 2u raised to power minus 3 multiplied by 3. Minus 2 multiplied by 3, we have minus 6u raised to power minus 3. Then substitute u for 3x minus 1. dy over dx is equals to minus 6 into bracket 3x minus 1 raised to power minus 3. Question 59. Evaluate this expression. For you to evaluate this expression, let's check the procedure for solving this. Apply the principle of definite integer, that is this principle. For us to do this, we first find the indefinite integer using this expression. Let's check the solution. Here is our question. We have nx raised to power n plus 1 over n plus 1 plus c. We have 3x raised to power 3 plus 1 over 3 plus 1 plus 4x plus c equals to 3x raised to power 4 over 4 plus 4x plus c. When you add this thing together, you have 4. When you add this also together, you have 4. We now have this expression. Apply this theorem. We have substitutes for the upper limit here and the lower limit here. Our upper limit is 2 and our lower limit is 0. When you substitute for 2, we have 3 into bracket 16, that is 2 raised to power 4 over 4 plus 4 into bracket of 2 plus c, minus when you substitute for the lower limit, we have 3 into bracket 0 over 4 plus 4 into bracket of 0 plus c. We now have 3 multiplied by 16, 48 over 4 plus 8 plus c, minus 3 multiplied by 0, 0 over 4 plus 0 plus c. 48 over 4 plus 8 plus c, minus when you add this thing together, you have c. Then let's subtract. We have 20 plus c minus c equals to 20. Question 60. If y is equals to 3x squared plus 5x plus 1, find the y over the s at x equals to 2 over 3. Let's check the procedure for solving this. Apply the general principle where y is equals to ax raised to power n. Then the derivative of y is equals to n multiplied by ax raised to power n minus 1 for each term, where a and n are n constants, that is multiply the coefficient of x by the power n and reduce the power of x by 1, then substitute x for 2 over 3. Let's check the solution. Here is our expression. We apply the general principle. For each terms, we are going to apply the general principle. We are going to have 3 multiplied by 2, that is n multiplied by a. 3 multiplied by 2x squared minus 1 plus 5 multiplied by 1x raised to power 1 minus 1. We have 3 multiplied by 2, 6x raised to power 1 plus 5 multiplied by 1, we have 5x. 1 minus 1, we have 0, that is 5x raised to power 0. dy dx now is equals to 6x plus 5, anything raised to power 0 is 1. 5 multiplied by 1. dy dx is equals to 6x plus 5. Then let's substitute x for 2 over 3. We have 6 into brackets 2 over 3 plus 5. We now have 6 multiplied by 2 over 3. We have 4 plus 5 equals to 9. Therefore, dy dx is equals to 9.